Hey guys, welcome back. This is lesson 8.3, functions and equations. Just a couple terms to get down before we get started. Linear functions. The key to linear functions is they have to be a straight line. And that means that it increases or decreases at a constant rate. Now, we're going to see it on our coordinate grid. So here I have my x and y axis here. And I'll show you an example of what a linear function looks like. It would be a straight line. And in order to show it as a straight line, make sure you have a ruler or straight edge, something to make it straight. So here I have, boom, and I'll draw a straight line. Perfect. Now I'm going to draw little arrows to signify that it increases or decreases at a constant rate, and it is a straight line. Those arrows show that it goes on forever. Non-linear would be, if I draw my x and y axis again, if it has any kind of curvature at all to it, it is non-linear. An example would be something like this. That is non-linear for obvious reasons. It has a gigantic curve in it. But as I said, linear, straight line, non-linear, has any kind of curvature to it whatsoever. Okay, so let's look at this one here. What we have to do is figure out, is the below equation linear or non-linear? And we're going to have to do that by first solving our table. Y equals x plus 4. And here's my x's, and here's my y's. So what I want to do is substitute each of my x values to figure out what my corresponding y value will be. So here I have, if x equals 2, it would be 2 plus 4, which is 6, which means y equals 6. But if x equals 3, it would be 3 plus 4, or 7. 4 plus 4 is 8, so y would equal 8. Now I'm noticing that it goes up 1, up 1, up 1, plus 1, plus 1. That sounds like it could be linear, but the only real way to know would be get our pairs, graph them. If it's a straight line, we're good. Then it is linear. I've gone ahead and I've made our x and y axis here. Now let's make ordered pairs. This is just the same box that we did previous. I just put it here so we can remember what the numbers were. So our x is 2, our y is 6, our x is 3, our y is 7, and last one, our x is 4, and our y is 8. Okay, we have our ordered pairs. We need to graph them to figure out if it's linear or not. So our first one is 2, 6. I go over 2. 1, 2. Up 6. 1, 2, 3, 4, 5, 6. Perfect. The next one is 3, 7. So I go over 1, 2, 3. And I go up 1, 2, 3, 4, 5, 6, 7. Okay. Our next one is 4, 8. So I go 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. Okay. It looks good. Got my straight edge handy. Line them up. And I will draw my arrows to show that yes, it will go on forever. Is it linear? Yes, it is. Here's my graph to prove it. No curves, linear. Okay. Here what we have to do is figure out what is my equation. What is my equation involving xy that will solve this table? So let's look at it. 0, 1, 2, 3 is my x. My y is 10, 15, 20, 25. So let's look at our y, which is our output. Remember back with inputs and outputs? My input is 0, my output is 10. My input is 1, my output is 15. So we need to figure out, what is that function? What is going on to get from 0 to 10? So first you might look at it and say, oh, 0 plus 10 is 10. But is 1 plus 10 15? Is 2 plus 10 20? Nope, it's not. It's a little bit deeper than that. So let's see if we can figure out a pattern with our y's. I see 10, 15, 20, 25. Now looking at it, you could tell that it is going plus 5. Plus 5. Plus 5. Okay. And these are all increasing by 1s, which is good, and that's going to help us. So let's see. If we know that plus 5, so we know it's 5, so we know it's x's times 5. So we know it's going to be 5 times x. But it's more than that. So let's see what more. If I just do 5 times x, and my x is 0, it's going to be 5 times 0. Well, that's just 0. But how do I get to 10? Maybe add 10? 0 plus 10? Ooh, that gives me 10. That gives me 10. So let's see if this works. 5x plus 10. I think, right now we're just going to guess and check, and we'll revise if we have to, but let's just see if this one works. 5 times x plus 10. Well, 5 times 0 is 0, plus 10. Ooh, that does equal 10. Let's try this one. 5 times 1 plus 10. 5 times 1 is 5, plus 10. Ooh, 15. That's good. Let's try 5 times 2 plus 10. 5 times 2 is 10, plus 10. Ooh, that does equal 20. We are good. What about 5 times 3 plus 10? 5 times 3 is 15 plus 10. 15 plus 10 is 25. Perfect. That is good. So our equation is simply 5x plus 10. We make it an equation by saying equals y. Because that means for every x that we put in here, we're going to figure out what y is. We can continue this pattern on and say if our x is 5, we would just say 5 times 5 plus 10. 5 times 5 is 25 plus 10, and that would be 35. So our x would be 5, our y would be 35. Okay? Any questions you have, jot them down. We'll talk about it in class. We'll see you at class.